Till now in set theory, I already discussed set operations, functions. Next topic is sequences and summation. Although it is not important for GATE, but I will discuss as it will help you in algorithm, TOC and discrete math. First, what is sequence? We can say sequence is a order list. There can be two type of sequence. One is finite, another is infinite. This is an example of finite sequence and this is an example of infinite sequence. Now, definition of sequence. A sequence is a function from a subset of the set of integers to a set S. We use the notation an to denote the image of integer n. We call a n as a term of the sequence. So, in the sequence, individual are term. Let's see one example of sequence. Consider the sequence an where an equals to 1 divide n. So the list of term in this sequence start with a1, then a1, a2, a3, a4, a5 like this. So a1 will be 1 by 1. 1 divide 1, it's 1. a2 will be 1 divide 2. Then a3 will be 1 divide 3. a4 will be 1 divide 4, a5 will be 1 divide 5 like this. So this is a sequence 1, 1 divide 2, 1 divide 3, 1 divide 4, 1 divide 5. We can say an equals to 1 divide n. Now definition 2, it's about the popular sequence GP or you can say geometric progression. So geometric progression is a sequence of the form AR square, AR power n like this. Here initial term is the A and the common ratio is R. So let's take A equals to 2, R equals to 3. Then what will be sequence? It will be 2, then a multiplication r, so 2 multiplied 3, then 2 multiplied 3 square, then 2 multiplied 3 cube like this. So 2 multiplied 3 power n. Here the function is ar power x and sum of the GP finite sequence will be a r power n minus 1 divide r minus 1, or you can alter a 1 minus r power n divide 1 minus r if r not equals to 1. So this formula is for sum of a GP. One GP is given and if you want to find sum of that sequence, these are the formula if r not equals to 1. If r equals to 1, it will simply an. Means if r will be 1, then it will be a like n term. Now their addition will be a multiplied n. This is all about finite sequence summation. If the sequence is infinite, then sum will be a divide 1 minus r. It's all about GP. Next I will discuss AP, arithmetic progression. In GP, every term we multiply by r. Here in AP, in every term we add by d. So here initial term is a and common difference is d, and every time we'll add d. So arithmetic progression is a sequence of the form a plus d, a plus 2d till a plus nd, where initial term is the a and the common difference is the d, and a, d both are real number. Let's take an example. Suppose a equals to 2 and d equals to 3. So what will be the AP? Initial term is 2, so a will be 2, then 2 plus 3, then 2 plus 3 multiplication 2, then 2 plus 3 multiplication 3, then 2 plus 3 multiplication 4 like this. So 2 plus 3, here 2 plus 3 plus 3, here 2 plus 3 plus 3 plus 3 like this. So every time we are adding d into the term. So here what will be function? Function will be a plus dx. D is the common difference. Now sum of AP will be n divide 2, 2a plus n minus 1d. This is when we don't know about the last term. If you know the last term, then sum will be a1, that is the first term plus last term multiplication n divide 2. When is known and here an is not known. And the finite sequence called as a string. In TOC we use the term string a lot. So this string can be denoted as A1, A2 till AN. And the length of the string are the number of terms in that string. If one string contains 0 term, then we can say it's a empty string and its length will be 0. And empty string can be denoted by epsilon. In some book you will also see this symbol gamma. So these are the symbol for empty strings. Next, definition 4, it's about recurrence relation. From the recurrence relation we can get a sequence. So a recurrence relation for the sequence an is an equation that expresses an in term of one or more of the previous term of the sequence. So namely a0, a1 till an minus 1 for all integer n with n greater than equals to n0, where n0 is a non-negative integer or we can say positive integer. A sequence is called a solution of a recurrence relation if its terms satisfy the recurrence relation. So from the recurrence relation we can get a sequence as a solution. Let's see one example. Let a n be a sequence that satisfies the recurrence relation. A n equals to a n minus 1 plus 3. Here n equals to positive integers, so 1 to 3 till infinite, and suppose that a0 equals to 2. So here initial term, that is a0 equals to 2 and an equals to an minus 1 plus 3. This is our recurrence relation. Now what will be a1? a1 will be n minus 1, so it will be a0 plus 3. 2 plus 3, it will be 5. Now what will be a2? a2 will be a1 plus 3. So it will be 5 plus 3 equals to 8. What will be a3? a3 will be a2 plus 3. 8 plus 3, it will be 11. So from this recurrence relation we got the sequence like 2, 5, 8, 11. This is a sequence that we got from this recurrence relation. an equals to an minus 1 plus 3. In today's lecture, I discussed what is sequence, what is geometric progression, what is arithmetic progression, and what is recurrence relation. In next lecture, I will discuss some more example of recurrence relation. If today's lecture is helpful for you, please like, share, and subscribe. Thank you.